So yeah, so under annuity question A, they say face mask COVID-1 of the student at the graduate school of business has won a lottery paying 60,000 per year for 15 years. Face mask is to receive her first payment a year from now, and the state advertised this as a million kwacha lottery because 1 million equals to 60,000 times 15 years. If the interest rate is 12%, what is the true value of the lottery? So that's the first question. If the interest rate is 12%, what is the true value of the lottery? Then the other question, they are saying Paul has just been offered a job at 100,000 per year. Paul expects his salary to increase by 10% a year until his retirement in 40 years. So given an interest rate of 20%, what is the present value of his lifetime salary? Okay, so we have two questions under annuity. There's the first one and the second one. So for the second one, which is the B part, it's about growing annuity. So for growing annuity is a situation where your salary or your cash flow is not constant, it keeps on increasing each year. Like an example, in this B, we have been told that his salary is to increase by 10% a year until his retirement in 40 years. So the keyword there is the increase of 10% a year. So we can start with the first one. So the first one, they're asking us to find the true value of a lottery. So true value is simply just finding the present value. So in this case, we want to find the present value of the lottery. So present value of an annuity is given like this, the formula. Present value, which is PV, is equal to cash flow, open brackets. Then we have 1 over R minus 1 over R. Then we are multiplying with 1 plus R to the power T. Okay, so C stands for the cash flow. How much are you receiving per year? Like in the case of question A, we have been told that this person is going to be receiving or is going to be making payment of 60,000 kwacha per year. So that's our cash flow. Okay, then for R stands for the discount rate or the interest rate. So for A, we have been told that the interest rate is 12%. Then T is standing for time, of course in years. So according to the first question, our time is 15 years. So we can simply find the true value of the lottery just replacing what we have. Our C, we said it's 60,000. Okay, then we say 1 over our rate is 12%, so we are supposed to express it in decimal points. So 12% is the same as 0.12, then minus 1 over again 0.121 plus 0.12 to the power time is 15 years, so we put 15 years. Okay, so we can continue simplifying this. So we'll say 60,000. Okay, so here I can divide 1 over 0.12, which is giving me 8.33 when you punch on the calculator. Then minus, so here I'll add 1 plus 0.12. It's going to give me 1.12. Then 1.12 to the power 15. Then the answer that I'm going to get, I multiply it with 0.12. So when I do that, it's giving me, just on the down part, it's giving me 0.6568278. Then on top, of course, we have a 1. Okay, so after I do that, I can divide these two. So we're going to have 60,000, open brackets, I have 8.3333. Then this side, when I divide, it's giving me 1.522469. Okay, so we can subtract what's in the brackets this side. So we have 60,000. Then here, when I subtract, it's giving me 6.81861. Okay, so I can multiply here. So when I multiply what's in the brackets by 60,000, it's giving me 400,008 651.66. So this is our true value for this lottery. Yeah, so just a quick recap. So we said we are answering the question for annuity. So annuity is just a series of equal payments that are made at regular interval in a given period of time. So like in this case, we are given a period of 15 years. Okay, so finding the present value of an annuity, this is the formula that we use. Present value is just cash flow 1 over R minus 1 over R open brackets 1 plus R to the power t, where C is standing for the cash flow, then R is the interest rate, of which you're supposed to put in decimal points. T is standing for time in years. Then for question B, let me read it once more. So they are saying Paul has just been offered a job at 100,000 kwacha per year, and Paul expects his salary to increase by 10% a year until his retirement in 40 years. Given an interest rate of 20%, what is the present value of his lifetime salary? So this one is also under annuity, but it's growing annuity, because our cash flow, the 100,000, is not going to be constant. It's going to be increasing by 10% each year. So now what is the formula for growing annuity? How do we find the present value of growing annuity? The formula for growing annuity is given by this. So present value of growing annuity is equal to cash flow open brackets. We have 1 over R minus G. Then we are subtracting by 1 over R minus G. Then we multiply by open brackets 1 plus G over 1 plus R, then to the power T. So this is the formula for growing annuity. C stands for the cash flow, R stands for the interest rate, of course in decimal points, then G stands for the percent at which your cash flow is growing. In this percent, you have been told that the salary is going to be increasing by 10% each year. So 10% is standing for G, because G is standing for the growth rate, the percentage at which your cash flow is growing each year. Okay. Then T is just time in years. In this case, we have been told that it's going for 40 years. So we can find the present value by just putting the figures that we have. What's our cash flow? We have been told that it's 100,000. Okay. Then we say 1 over, what's our rate? Interest rate, we are told it's 20%. So 20% in decimal points is the same as 0.2. Then minus our growth rate. We have been told that the salary is going to be increasing by 10%. So our G is 10%. In decimal point is the same as 0.1. Then we are subtracting by 1 over our rate, still 0.2, minus our G, 0.1. Okay. When we do that, then we are going to multiply by this, where we have 1 plus G, which is 0.1, over 1 plus 0.2. To the power, it's going for 40 years. We put 40. Okay. So after we do that, we can work with what's in the brackets. Okay. So I can subtract what is down here, then I divide into 1. I see what I'm going to get. So 0.2 minus 0.1, the answer that I find when I divide into 1, it's giving me 10. So outside I have 100,000. Then this side I've gotten 10 when I divide here, of which when I do here, it will give me the same, which is 10, because it's just one and the same figure. So it's giving me 10. Then I'm multiplying 10 with what is this side. Okay. So I'll multiply 10 with what's this side. So here I can add 1 plus 0.1 and 1 plus 0.2. So 1 plus 0.1 is giving me 1.1 on top. Then down I'm going to have 1.2. So 1.1 divided by 1.2. The answer that I find, I say to the power 40. It's giving me 0.916666. Okay. So when I divide what is inside, it's giving me this. Then I'm going to say what I've gotten after dividing what's inside to the power 14. Then we see what it's going to give me. Okay, so you can continue by saying 100,000. Then here I have 10 minus. Okay, so when I do what is in the brackets to the power 14, then I multiply by 10. Then when I do that, so when I divide, it's giving me 0.00307933385. Okay, so I can subtract what is here. When I subtract, it's giving me 9.6920666 Okay, then I can multiply 100,000 with that. So when I multiply by 100,000, I'm getting 969,206.61. So this is the present value. So just a quick recap. For growing annuity, the formula we said is this one. There is an introduction of G. So the formula for growing annuity, we have this one, where R is standing for the interest rate, G is standing for a percent at which your cash flow is growing. And in the question, we were told that the person is to have a cash flow of 100,000. So we replace what we had in the formula. Then when multiplying, don't start by subtracting these two, because you can get a 0. So first work out everything this side. So when you do whatever is this side, then you subtract from the figure that is here, which is the 10. So here you come with the 10 until you finish everything this side. That's when you can subtract from 10. You have this, you multiply by 100,000, then you get your present value.